Okay, we're asked to calculate the directions or the azimuths of each side of a regular hexagon, given that the side AB has this direction, 95 degrees. That's from north. So this angle right here is 95 degrees, 14 minutes, 26 seconds. And here's the list of the azimuths. Question is, how do we calculate those? And by the way, you need to know that all the interior angles of a regular hexagon are 120 degrees. You can use the formula that's derived by creating diagonals from one vertex, that n minus 2, where n is 6, tells you that there's 4 triangles, each having interior angles adding up to 180. And then if you divide by 6, you get the measure of each interior angle. Okay, so how do we get what are we doing here? I took the original azimuth, which I didn't show the 14 degrees, 26 minutes, added 180, subtracted 120, and that gave me the direction of this side of the hexagon, which looks like it's 155 degrees. So if you could picture a grid right here where this is north, this angle is 155 degrees. Now, why does this formula work? Well, let's go to board 2. So here is side AB extended with this green dashed line. And if I put this north-south grid, north-south-east-west grid on point B, this angle is 95 degrees. If I add 180 to that, that'll take me to the back azimuth, which is the direction of BA. And now if I subtract 120 degrees from whatever number that is, which is what, 95, 5, 17, what, 275. If I subtract 120, that'll take me back to here. Okay. Now, I could have added 120 to the back azimuth, and that would have taken me in this direction, and point C would be up here. But that seems to conflict with the C is westerly from point B. So that's why we have this direction down here. Okay, and if I subtract 120, there's the 155 that we got on the previous board. And we'll do one more. At point C, here's the grid. Here's the extension of side BC, 155 degree angle from north. If I add 180, that'll give me the back azimuth. So think 180 here. And then subtract 120. And that takes me back to here, giving me the direction of this side of the hexagon with respect to north. Okay. Now I'm going to share my screen and show you where I got all this stuff. Entire screen. Share. Here is the hexagon. And if I click on point A, we get rid of the grid. So you can click on each of these vertices to display the grid at that point. Here's the grid on D. We know the, whoops. Normally I lock the viewport. So I will do that here. So this green dashed line is the extension of CD. Add 180. You have the direction of DC. Subtract 120, and you've got the direction of DE, or the azimuth. Okay, there you go. Hope that helped. If you have any questions, post a comment, and I will post a link to that Desmos graph.